Can we create a black hole? Not the kind that swallows stars, of course. I'm talking about something tiny, microscopic even, something that could fit on your fingertip. Could we recreate one of the universe's most extreme objects right here on Earth? Recently, scientists have been trying to do just that. They're not using massive stars or powerful gravity. Instead, they're using lasers, particles, and some of the most complex machines ever built. Why? Because black holes are fascinating. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. The thought of something so dense, so powerful is captivating. It's a mystery we're driven to understand, but studying a black hole billions of light years away is hard. Creating one in a lab, well, that would be a game changer. Black holes sound like something out of science fiction, regions of space-time where the laws of physics as we know them break down, places of immense gravity where time itself slows to a crawl. They are born from the death throes of massive stars, collapsing under their own weight. Their pull is so strong that they consume everything that gets too close. Light, matter, even other black holes, nothing is spared. This makes them invisible to our telescopes, shrouded in a veil of darkness. We can only detect them indirectly by observing their effects on the surrounding matter. Imagine the possibilities if we could create and study a black hole up close. We could unlock secrets about the universe's origins, the nature of gravity, and perhaps even the fate of the cosmos itself. It's a tantalizing prospect, one that drives scientists to push the boundaries of what's possible. Black holes are formed when massive stars die. As the star's fuel runs out, it can no longer support its own weight. The core collapses in on itself, creating a point of infinite density called a singularity. The gravity around the singularity becomes so strong that it warps the fabric of space-time, creating a region from which nothing can escape, the black hole. Recreating this process in a lab is a monumental challenge. We can't simply crush matter with enough force, as stars do. The energies involved are far beyond our current capabilities. Instead, scientists are exploring alternative approaches, using high-energy collisions to create miniature black holes. So, recreating the cosmos in the lab. One such experiment involves using powerful lasers to accelerate particles to near the speed of light. These particles, typically protons or ions, are then smashed together in a carefully controlled environment. The idea is that at such high energies, the collision might create conditions similar to those found in the early universe or near a black hole. These miniature black holes, if they form, would be incredibly small and short-lived. They would evaporate almost instantly due to a phenomenon called Hawking radiation. To detect these fleeting events, scientists use sophisticated detectors that surround the collision point. These detectors can track the paths and energies of particles produced in the collision, searching for telltale signs of a black hole's creation and subsequent evaporation. Did we do it? So, have we succeeded in creating a black hole in a lab? The answer so far is no. Despite our best efforts, we haven't yet observed definitive evidence of miniature black hole creation. The energies required are at the very limits of our current technology. And even if we could create them, detecting their fleeting existence is incredibly challenging. But this doesn't mean we've failed. The pursuit of knowledge is a journey, not a destination.